Even a tiny vibration at the wrong frequency can create total resonance. We have to find that sweet spot.
At an aerospace facility outside Seattle, Daniel Brooks arrived before sunrise with grease on his hands and a backpack for his daughter. He was a single dad and experienced mechanic, not an engineer. Nobody expected him inside the hangar, where elite engineers had spent 3 frustrating days fighting a mysterious propeller. The aircraft belonged to a powerful aviation company developing a next-generation electric commuter plane. Its propeller system had failed during testing, producing violent vibrations whenever engineers increased power. Specialists from several states examined the machine. Computer models looked perfect. Measurements seemed normal, yet the propeller shook dangerously whenever it accelerated. Daniel had been hired temporarily to maintain support vehicles and ground equipment. He understood that his position was far below the engineers overseeing the project. Still, while unloading tools, he heard the propeller running inside the hangar. The strange rhythm immediately caught his attention. It sounded uneven, like a heartbeat. Inside, engineers surrounded the aircraft with laptops, sensors, and technical manuals. Project Director Victoria Sterling watched anxiously as another test ended with the same violent vibration. One engineer blamed software, another suspected the motor. A third insisted the blades were perfectly balanced. Nobody noticed Daniel quietly listening from the doorway. Victoria finally noticed him and asked whether he needed something. Daniel apologized and said he had only been listening. An engineer laughed, asking whether the maintenance mechanic had suddenly become an aerospace scientist. Daniel ignored the insult. He simply asked how the vibration changed when the propeller reached different speeds. The engineers reluctantly explained their results. The vibration appeared only within a narrow range, then disappeared above it. Daniel asked whether anyone had tested the propeller without the electronic control system. They stared at him. One engineer explained that the software maintained rotational stability, making his question sound almost ridiculous. Daniel walked closer, keeping his hands behind his back. He studied the spinning blades and listened again. The sound changed each time the aircraft reached the troublesome speed. Daniel remembered repairing fans years earlier. Sometimes, he explained, a system could be perfectly balanced while still creating resonance under operating conditions. Victoria became interested. She asked Daniel what he thought was happening. Daniel admitted he was not certain, but suspected airflow resonance combined with a tiny, flexible component. The chief engineer objected immediately. Their sensors showed no significant imbalance. Daniel replied that sensors measured numbers, while his ears noticed behavior too. Nobody accepted his explanation. The engineers restarted their simulation, and Daniel stepped outside. While waiting, he noticed his daughter, Mia, sitting in the family car, spinning a small fidget spinner between her fingers. She had brought it because she liked the calming motion. Daniel suddenly watched its 3 arms move unevenly. Mia asked why he was staring. Daniel took the spinner and rotated it slowly. When he held one arm lightly, the entire object developed a faint vibration. When he changed his grip, the vibration shifted. Daniel understood the propeller problem differently. A flexible part could alter resonance without appearing mechanically broken. Daniel hurried back inside and asked for a simple demonstration model. The engineers were skeptical, but Victoria allowed it. Daniel placed the fidget spinner on a workbench and spun it at different speeds, then gently changed pressure on its center. The vibration changed instantly. The room became completely silent. Daniel explained that the spinner was not a solution for the aircraft. It was a visual model showing how changes in mass distribution and flexibility could create resonance at speeds. He believed one propeller blade had microscopic flexibility caused by manufacturing tolerance. The sensors had measured balance, not dynamic behavior. The chief engineer reluctantly inspected the blade assembly again. Using specialized equipment, the team discovered a tiny difference in stiffness between 2 blade mounts. It was within manufacturing specifications, so nobody considered it dangerous. Yet at one precise rotational frequency, the difference created a repeating vibration that multiplied dramatically indeed. Victoria immediately ordered another controlled test. The engineers adjusted the suspected mount and installed additional vibration sensors around the propeller hub. Daniel watched from behind the safety barrier with Mia beside him. When the aircraft reached the troublesome speed, everyone held their breath. The propeller remained almost perfectly smooth again. The hangar erupted in stunned applause. The chief engineer stared at Daniel, clearly embarrassed but impressed. Victoria walked toward him and asked how he had recognized something their advanced computers had missed. Daniel shrugged and said, "I've fixed enough broken machines to know they don't always tell you what hurts." The story spread quickly through the company. Daniel's simple fidget spinner became an unlikely symbol of the breakthrough. Engineers began studying his practical approach, combining traditional mechanical intuition with advanced digital testing. Victoria offered Daniel a permanent position, but he hesitated because his daughter's needs always came before his career. Victoria understood and offered him a flexible schedule instead. Daniel accepted, becoming a mechanical diagnostics specialist who worked alongside the engineering team. He never pretended to know everything. Instead, he asked questions, listened carefully, and tested assumptions. The engineers gradually learned that expertise could come from experience, observation, and persistence. Weeks later, the aircraft completed a successful flight test over Washington. Daniel watched from the runway with Mia holding his hand. When the propeller accelerated smoothly, Mia raised her little fidget spinner like a trophy. Daniel laughed. Victoria stood nearby, realizing the company had discovered more than a mechanical solution. They had discovered a new way of solving problems. The engineers still used mathematics, simulations, and sensors, but they also began listening to machines differently. Daniel's lesson was simple. Complicated technology could hide simple physical truths. Sometimes the smallest clue, noticed by someone willing to pay attention, could unlock everything. That evening, Daniel drove home with Mia, asleep in the passenger seat. Her fidget spinner rested in the cup holder. Daniel smiled whenever looking at it. He had entered the aerospace facility as an ordinary mechanic and left with new respect, a new career, and one unforgettable reminder: curiosity could outrun credentials.